Just days ago, NASA uncovered the clearest sign of life we've ever seen on Mars. Hidden deep inside an ancient Martian riverbed, untouched for billions of years. Perseverance found strange organic patterns never seen before. If they're real, it could rewrite everything we know about life in the universe. But what excites scientists also terrifies them. Because what if it's not just life, but something far more alien? The Perseverance rover landed in Jezero Crater, a dried-up lakebed rich with clay minerals, selected for its potential to preserve biosignatures, signs of past life. This mission, launched in 2020, aims to uncover whether Mars was once habitable by collecting and analyzing rock samples. Jezero is like a time capsule, holding clues to Mars' watery past and possibly its biological history. Astrobiology, the science of life's origins and presence beyond Earth, guides this search. While many expected signs of ancient life in the oldest rocks, Perseverance's 2024 discovery shifted the mission's trajectory, revealing that younger sediments may also hold secrets. In July 2024, specifically on Sol 1212, July 18th Earth time, NASA's Perseverance rover reached the northern edge of Neretva Vallis, an ancient river valley about a quarter-mile wide, carved by water rushing into Jezero Crater billions of years ago. There, amid the rocky outcrops of the Bright Angel Formation, it encountered an arrowhead-shaped rock measuring 3.2 feet by 2 feet, nicknamed Shayava Falls after a Grand Canyon waterfall. This reddish mudstone, laced with large white calcium sulfate veins filled with millimeter-size olivine crystals and hematite bands giving Mars its rusty hue, stood out immediately to the science team. Perseverance's instruments, Pixel for X-ray chemistry mapping elements atom by atom, and Sherlock for detecting organics, scanned the surface, revealing colorful leopard spots, tiny black poppy seeds, and larger rings rich in organic carbon, sulfur, oxidized iron like purple-pink vivianite and yellow-green greigite, plus high phosphorus levels. These spots suggest chemical reactions, possibly powered by ancient microbes using the rock's ingredients as an energy source, forming patterns too complex for simple geology alone, with no signs of high heat or acidity that would destroy organics. On July 21st, Sol 1215, after abrading the surface to expose fresh material, the rover drilled its 22nd core sample, labeled Sapphire Canyon, sealing this potential time capsule for Earth's labs. Scientists call it the strongest biosignature candidate yet. Not proof of life, but a tantalizing match to microbial features on Earth, remarkably from some of Mars' younger sediments analyzed so far. The combination feels alive with possibility, evoking an ancient Martian world teeming beneath watery flows. Yet a question haunts. What if nature's chemistry alone forged these spots without biology? Before embracing this as proof of life, scientists rigorously test every alternative explanation. Volcanic activity could deposit minerals mimicking these patterns, but Shayava Falls shows no heat signatures that would alter the organics. Acidic water flows might explain iron oxidation and sulfur enrichment. Yet the rock's olivine crystals remain intact. Olivine dissolves rapidly in acid, ruling out prolonged harsh conditions. Geochemical reactions like serpentinization, where water interacts with mantle rocks, produce similar iron-sulfur compounds, but the precise leopard spot distribution and organic carbon concentrations exceed typical abiotic models. NASA's Pixel mapped these elements atom by atom, confirming chemical gradients too organized for random geology. Sherlock detected organics resistant to degradation, challenging purely environmental origins. International teams modeled these processes using Earth analogs, systematically eliminating non-biological causes while acknowledging gaps only Earth labs can fill. Each ruled-out theory narrows the possibilities, heightening the case for biology without declaring victory. The presence of vivianite and greigite, phosphorus-rich iron minerals linked to microbial metabolism on Earth, further complicates abiotic explanations, as their formation requires specific energy gradients. Yet, scientists maintain measured optimism. Extraordinary claims demand extraordinary evidence. If it's not volcanism, not acidity, not geochemistry, then what's left? The tension builds as biology emerges as the leading hypothesis. Throughout decades of Mars exploration, the search for life has been a roller coaster of hope and disappointment. The Viking landers in 1976 first attempted to detect biological activity directly, but returned ambiguous results that scientists still debate. Then, in 1996, excitement peaked when the ALH 84001 meteorite, believed to have come from Mars, showed possible fossilized microbes, only for further analysis to cast doubt on those findings. The Phoenix lander's 2008 discovery of simple organic molecules and water ice also raised hopes, but no definitive signs of life emerged. These false positives taught NASA valuable lessons in scientific rigor and caution. Each time, the agency set higher standards for evidence, understanding the stakes of premature claims. That's why, with Cheyava Falls, despite the strong potential biosignatures and unprecedented detail, NASA remains deliberately cautious. The difference now is the combination of multiple lines of evidence from state-of-the-art instruments like Pixel and Sherlock, cross-verified internationally, and samples prepared for return to Earth labs for more sophisticated analysis. Unlike earlier missions, Perseverance's discovery benefits from detailed chemical mapping showing two iron minerals, vivianite and greigite, linked to microbial metabolism on Earth. The rock's composition, preserved in the Bright Angel Formation, and the discovery of organic molecules in a younger sedimentary rock add confidence. Still, history reminds us that extraordinary claims require extraordinary evidence. NASA's careful peer-reviewed process and transparent communication reflect this hard-earned wisdom. While curiosity and hope rise, humility grounds the mission, recognizing the profound challenge of confirming life beyond Earth. The discovery of potential life on Mars resonates far beyond planetary science. If the biosignatures found in the Cheyava Falls rock fully confirm ancient Martian microbes, it means life is likely common in the universe, not a rare Earth-only phenomenon. This would significantly impact the Drake equation, a framework used to estimate the number of communicative civilizations in our galaxy by increasing one of its fundamental variables, the probability of life emerging wherever conditions permit. This finding also challenges the so-called 0-1 infinity rule in astrobiology, which posits that life is either incredibly scarce, 0, unique to Earth, 1, or widespread throughout the cosmos, infinity. Confirming microbial life on Mars would powerfully support the infinity scenario, suggesting that life naturally arises on planets with the right environment and ingredients, making the universe much more alive than previously imagined. Beyond the science, the confirmation of alien life would profoundly alter human self-understanding. It would confront long-held views of humanity's isolation, potentially reshaping philosophy, religion, and culture. It would inspire profound awe about our connection to the wider cosmos, urging global collaboration in the search for knowledge and protecting planetary ecosystems. Emotionally, it is a humbling and inspiring moment, transforming the way we see ourselves as cosmic explorers part of a living universe. Yet, the scientific community emphasizes caution. This discovery demands extraordinary proof before rewriting textbooks or redefining biology. The stakes are enormous. Scientific rigor and methodological integrity must guide each step forward. We balance excitement and restraint, recognizing science's strength lies in patience and evidence, ensuring this moment becomes a foundation for truth, not premature conclusions. NASA's Perseverance rover's intriguing discovery is only the beginning in humanity's quest to confirm life on Mars. The next crucial step is the Mars Sample Return Mission, a complex endeavor designed to bring Martian rock and soil samples back to Earth for detailed laboratory analysis. Perseverance has already collected core samples, including the one from Chayava Falls, but the definitive answers lie in the hands of scientists on Earth, equipped with instruments far more advanced and sensitive than those on the rover. This mission involves several phases. First, gathering and caching samples on Mars. Next, an ascent vehicle will carry the samples into Martian orbit. Finally, a spacecraft will retrieve them and return them to Earth, where researchers can perform exhaustive tests. This multi-step process is technically challenging and costly, with many opportunities for delay or cancellation due to budgetary and political factors. Yet it remains the only feasible path for confirming biosignatures beyond reasonable doubt, turning tantalizing clues into concrete discoveries. The Mars Sample Return Mission represents an unprecedented cooperative effort between NASA and the European Space Agency. Its success would mark a historic milestone, allowing us to directly study Martian material with Earth-based laboratories capable of detecting subtle chemical and isotopic signatures that could definitively identify life. The stakes are high because proving life on Mars would revolutionize science and our place in the cosmos, rewriting textbooks and inspiring generations. Despite the challenges, this mission is underway, with hardware development progressing and launch windows planned in the 2030s. Perseverance's samples, preserved carefully in sterile containers, sit awaiting their journey back. This patient, painstaking approach reflects the scientific rigor demanded by such an extraordinary discovery, transforming suspicion into knowledge and hope into evidence. Once the Chayava Falls samples reach Earth, scientists will perform two definitive tests to determine if they contain biological origins. First, chirality analysis examines the handedness of amino acids. Life on Earth produces almost exclusively left-handed molecules, while abiotic processes create equal mixtures. Martian samples showing strong left-handed preference would strongly suggest biology. Second, carbon isotope ratios provide life's chemical fingerprint. Living organisms preferentially use lighter carbon 12 over heavier carbon 13, creating distinct ratios absent in most geological processes. These tests, proven reliable on Earth rocks, represent unambiguous biosignatures when both align with biological patterns. However, challenges remain. Mars' harsh radiation and geology could alter signatures, requiring careful interpretation against non-biological baselines. Earth's advanced labs, with mass spectrometers 1,000 times more sensitive than Perseverance's instruments, will provide clarity unattainable remotely. These tests could finally resolve whether Chayava Falls preserves ancient Martian life, or merely remarkable chemistry. NASA employs a structured confidence of life detection, COLD, scale, to assess and communicate the strength of potential biosignatures, ranging from Level 1, initial detection, to Level 7, definitive proof of life. This 7-step framework was developed to avoid premature declarations and ensure scientific rigor, allowing evidence to advance progressively from possible signals to confirmed discoveries. Java Falls currently holds a position around levels 3 or 4 on this scale. That means scientists have detected compelling chemical and mineral signals consistent with life, such as organic carbon, sulfur minerals, and phosphorus distributions arranged in patterns unlikely from random geology. But independent verification and elimination of all abiotic processes are still needed. Reaching level 4 involves confirming findings through independent instruments or teams, while level 5 demands rigorous statistical evidence showing life is more likely than any non-biological explanation. The highest level, 7, is reserved for unambiguous, reproducible proof, often requiring Earth-based lab analysis of returned samples to rule out all other possibilities. This scale provides transparency and manages public expectations, framing new discoveries within a context that highlights both excitement and caution. It exemplifies science's incremental journey from discovery to certainty, and helps maintain credibility by clearly communicating where on the confidence ladder each finding stands. Java Falls represents humanity's strongest clue, yet that we're not alone. A preserved snapshot of ancient Mars mirroring early Earth, challenging us to redefine life in the cosmos. The question endures: are we alone? Those samples hold the answer. For those thirsting for discovery and the mysteries that lie just beyond our reach, stay tuned. The next revelation could change everything, and you'll want to be the first to know. Subscribe and hit the bell to keep exploring the unknown with us.